All right, here we go. Let's take a look at the definite integral. So, last chapter we spent a lot of time drawing rectangles or trapezoids, approximating this area under the curve. This time we're actually going to start to calculate that exactly by hand, and in this section we're actually going to look at doing it with some simple geometric shapes here. So, we're not going to use the rectangles as much as let's try to take. Here's my integral from 0 to 4, from the lower bound to the upper bound of this function. So here's a graph of the my function here, and I want to integrate from 0 to 4. So what am I talking about? I'm talking about the area under the curve from here to here. So what is the area under the curve from 0 to 4? Well, in this case, this is going to be a semicircle. This is one of our basic shapes we can find, and I'm going to tell you in the directions. There will always be in the directions that yes, that is a semicircle. So what is the area of a circle? Well, it's pi r squared. So if I'm going to do pi r squared of a circle, half a circle, semicircle, cut that in half. So check this out. What's the radius of this bad boy? Boom, it's 2. This has a radius of 2, so this will really be what? This will be, if you square it, 4 pi over 2. And let's clean that up. I don't want to do 4 pi over 2. That's just going to be what? 2 pi. So if you want to put in the formula, you just plug the radius in, divide it by 2. Excellent. So the integral from 0 to 4 of this is going to be 2 pi. Awesome. How about this next shape? And I even broke it up from 4 to 8 here. So from 4 to 8, check this out. You can call this one a trapezoid. So I guess we are going to do trapezoid again. So base 1 looks like it's 1 wide. 1, 2, 3, 4 on the bottom. So if you add your bases, base 1, or B1 plus B2 divided by 2 times it by the h. What is the h of this thing? It looks like it's 2. So that's kind of nice. They cancel out. And what is the area of this? I'm going to clean up just so we can have a nice pretty picture here. If I add those all together, I'm going to say the area of this is 5. So we're going to use just some basic geometry to find these definite integrals. The end of the curve there is 5. This is kind of new though. Check out the next one. 8 to 12. If I look from 8 to 12, I'm finding the area under the curve here. Well, the area under the curve is negative now. It's underneath the curve. So I kind of stayed away from this. Calculated them last with the rectangles, but it can totally happen. You can have this area below the curve, and it will turn out to be negative. It's not a negative area. It's just a negative direction. So what is the base of this thing? It's 1, 2, 3, 4. The base, remember, it's 1/2 base times height. So it's 1/2 the base, which was 4. The height in this case was -2. So we're looking at what? This is -4. So we can get negatives for our integrals. Definitely going to happen. Excellent. So some properties we're going to pick up. We're really going to pick up some properties. What if I want to go 0 to 8? What would you do for 0 to 8? Well, it'd be the area under the curve from here to here. All this stuff. So add them together. This would just be 2 pi plus 5. And what about if I want to go all the way from 0 to 12? So just be careful. We got to take the positive, the 2 pi plus 5, subtract the negative. So it'll be 2 pi plus the 5 minus the 4, or really it's just 2 pi plus 1. Excellent. So, all right, there it is, the integral from 0 to 12. Awesome. Can we set up an integral here given a function? So I just gave you the picture because I wanted you to see the function. I already graphed it. This is 1/9 x cubed, so I graphed it right here. Here's what I want you to set the integral. Ooh, wasn't that cool? A little magic there. If I want to write the integral for this, what will this be? This will be the integral of what? It looks like that's -2, from -2 all the way up to 3. You can just write the f of x if you want, or you can put it in there. You can of the function right there. So if I give you a little shaded region, can you find it? How about this bad boy? Let's light it up. Woo! So you're going to have to shade that onto your paper. Take a little second there. And then what am I going to do for this one? It's the integral. It looks like it's going from -1 all the way over to 4. And in this case, you can call it the f of x, or if you want to write out the whole function, you can. And usually if this is not just one term, we put in parentheses and we say with respect to x. Awesome. Very good. So then I'm going to throw a tricky one at you. You think, oh, I got this, no problem. Ooh, what's different about this one? Well, we don't always have to do with respect to x. In this case, I'm doing it with respect to y. So see, I'm not going down to the x-axis, I'm going to the y-axis. So when you do this, we actually have to solve this thing for x. We're going to actually have to write our integral in terms of y. So what does that mean? Well, my integral is going from 1 to 5. But I can't use this because this is in terms of x. So what do I got to do? I'm actually going to solve this and say y minus 1 equals x squared. Then what am I going to do? I'm going to square root both sides. And remember, when you do that, you get a plus or a minus. Y minus 1 equals that. So this is in terms of y now. Is this the plus or the minus? If I'm talking about this side, this is the plus side. If I had it shade over here, it'd be the minus sign. So this is going to be the positive version of y minus 1 dy. So now I'm doing it with respect to y. So that's crazy. Something a little bit different there. We're not going to use that till like at the end of the year when we do solids and revolutions, but it will come up where it's not always with respect to x. It can be with respect to y or t or whatever you're dealing with there. Awesome. How about this? I want you to be able to sketch some basic ones. So this is kind of weird. I'm going to show you how to do this in the calculator to get the answer, but some basic ones we need to be able to do, not just for this chapter, but for chapters coming up. So something like this, we should know, yeah, this is a parabola. It opens down, crosses at 4. So it's up here at 4. There was that like a nice little trick for parabolas. They do the 1, 3, 5 rule, down 1 over 1, down 3 over 1, and then down 5, 1, 2, 3, 4, 5, if they all fit on there. But at least get these first 2 points just to get a rough idea. So a lot of times you just kind of have, without a calculator, you got to be able to sketch a rough graph. Something like, yeah, it's not too shabby. That worked out pretty well. Look at that. Excellent. Then can we put in the integration here? Sure, from -2, it's right here. Well, that's where it crossed. All the way up to 1, so it's going to be this. And let's just shade that in. It's kind of hard for me on this. Hope yours looks a little better than that. So that is the picture. How do I evaluate this? Well, this is not so much a friendly shape now. It's not like a nice semicircle or trapezoid. So I'm going to show you another way on the calculator. I think last time I showed you the int way to do it. How about if we graph it? So we can graph it 4 minus x squared. And I know I just said do that by hand, and then the first thing I do, what do? I graph it. I guess the way to check, but there it is. I want you to be able to do that without the calculator. Here's the part I want you to use the calculator for. If you go to second trace, if you go to calculate, we're going to say I want to integrate. What's the lower limit? I'm going to go from -2. Hit enter. What's the upper limit here? Type it in. I'm going to go to 1 and check this out. Woo! That's pretty cool. It goes ahead and shades it for you, plugs it in there. In fact, I'm going to bring that in here because that's so neat. There it is right there. So, and it tells you the answer. What is this? This is 9. The area of the shaded region there is 9. Super cool. How about square roots? So, ones I want you to know is parabolas, quadratics, square roots, lines, absolute values, maybe some cubics, just some basic stuff. And remember, they all move the same. This is in the grouping symbol, so it goes right 1, and it's a square root, so it kind of does the 1, 3, 5 rule sideways, though. And you can plug points if you want, put in 2 and see what you get. So there it is right there. Can I go ahead and integrate this from 2 to 3? So it's going to be from 2 to 3. And again, that's just not a friendly geometric shape right there. It's just weird. So we can put that in there. And now we definitely, for now, later on, we'll do it algebraically. But for now, we got to put in a calculator, which is pretty awesome. And let's take a look at the picture. And let's integrate that bad boy. We're going to do it from the integral from what? 2 was my lower limit to 3 was my upper limit. There it is right there. I'm going to bring them into our scene here. And if I integrate that, I get 1.21. I'm going to truncate 3 decimals. Awesome. Excellent. What is this last one? Well, this last one is just a line. It's just 1/3 x minus 1. So don't be tripped up because the way I wrote it, hopefully that doesn't mess you up. Crosses at -1, goes up 1 over 3. You can do dots this way, draw a straight line in there. Now this one, I think, when we integrate straight lines from what, -2, we're going to go from here all the way up to 4. So it's the area up here, the area is positive. Down here it's negative. So we could actually do this one by hand. These are triangles. I'm feeling a bit lazy though. I'm just going to go ahead and type it in. If it says use the calculator, might as well. Let's just do it. So we said it was x divided by 3 minus 1, and we should get that line. And then let's go ahead and integrate this. I can't remember what I said we were integrating from. Oh, there we go. -2 to 4. Boom, there it is. And you kind of see it. It's hard to see this. I could zoom in if I want to see that little nooks and crannies there. But this is going to work out to be -4. Awesome. So we're going to use the graphing feature way to find the integral. Same thing we were doing with derivatives. You could look at the graph, or you could just type it in the calculator straight up. Awesome. So let's wrap this bad boy up with some properties we need to know. Write these down. Have these. It's going to come in handy for really the rest of the time here. There is one property for zero integral. If you integrate any function from a to a, so if you're going to go from like 2 to 2, and if you want an example, some people like an example, like if I integrate from 2 to 2, x squared dx, well, what does that mean? You're going to get 0 every time because you're integrating just no area. There's nothing there. So that's the zero integral property. How about negation? This is one that'll trip you up if you're not careful. So notice what's going on here. I'm going from B to A instead of A to B. We always go A to B, low to high. Well, I'm going high to low. If that happens, well, it changes things. You got to put a negative in front. So if you went from like 1 to 3 of a function, wait, that's how we normally do it. If we went from 3 to 1, if we're going from the high to the low of the function, well, it's going to equal the negative version of that. So we're just going to put a negative in front. So always check the boundaries. If the high one's on bottom, you got to make it a negative. You got to flip it and make it a negative. All right, and I think that'll make more sense when we do a couple coming up here. How about this if I multiply by a constant? So k is going to be some constant. So if in here I have some kind of constant, what this means in real life, if I was integrating something from 1 to 2, let's say I was doing 2x squared, what this means you're allowed to do is you're allowed to pull this 2 out front. So you're allowed to say it's this. And you're probably like, right now, you're probably like, whatever, Mr. Bruss, that's not very important. Well, it turns out it's going to be really important. When we start to do this algebraically, that's going to save you a lot of headache pulling the constant out in front. For now, yeah, you're right. Probably doesn't worry you too much, but it's really going to help out. How about this? Can I break them up? Decomposition. So if C is sandwiched between A and B, I can take an integral from A to B, break it up from A to C plus C to B. And we kind of did that in the first picture. You know, we broke it up like 0 to 4, 4 to 8, the different parts, and you can add them all together. That's what that's talking about. And we can add integrals. If I have the integral of this, and what that looks like in normal function, let's say I was doing the integral from 1 to 2 of something like 2x squared plus 3x dx. So what does that mean? I can break this up into two integrals, 2x squared plus 2 dx plus the integral from 1 to 2 of 3x dx. And again, when we start doing algebraically, you're like, oh, that's awesome. That really helps. But for now, we're just kind of recognizing these properties. It's just something nice we can do. So same thing with subtraction. You can break up addition, subtraction. When you have a constant in there, you can pull it out front. If your boundaries are messed up, flip them back and change the sign, and we get that little 0 thing. Awesome. Let's do a couple of these, and we are done with this one. This is a fast one right here. I like this. If I give you a couple integrals here, so I don't even have a picture. I don't even know what the function is, but I know the value. I know the area of the curve between here and here is 4. Between here and here is -3. Between here and here is 8. Let's use some of these properties if I can, if they're possible here. So if I go 5 to 1, ooh, double check it. First of all, it doesn't match any of these up here, but remember I want to go low to high, so I'm going to go 1 to 5, but what does that do? It makes it the negative version of this. So you can flip it, make it negative. So what is 1/5 integral? It is -3, but a negative makes that positive 3. So that is 3 right there. Awesome. Can I go from -2 to 5? Sure. Because it's the f of x of both of these, I'm going from -2 to 1 is 4, plus 1 to 5 is -3. That's going to give me a big fat 1 there. So that's that decomposition property right there. Excellent. Can I break this one up? Sure. I can integrate the f of x plus, notice there's a 2 in here. I can pull that 2 out in front and say and I'm using my addition, so I've got two properties in one here. I was adding, I didn't do with respect to x, sorry. So I got two properties in here. I had the addition property, I had the constant property. So from -2 to 1 of the f of x is 4 plus 2 times the g of x, which was 8. So I'm looking at what, 20? Boom. Properties all day. Love it. How about this from 0 to 1? I come up here. Anyway, I can figure out what's going on from this function from 0 to 1. No, not enough information. You can't, in this case, not enough info, so not possible. Sometimes you can work some magic, but they didn't give me enough info. I know what's going on from -2 to 1 and from 1 to 5, but I don't know what's going on from 0 to 1. I don't have anything to work with there, so that one's not possible. Oh, we already kind of did this constant rule. This is the one where you pull the 3 out in front. Uh-oh, and my boundaries are messed, aren't they? The low should be down here, so Woo! -2 should be on bottom. The 1 should be on top. And I pull that 3 out. So when I did that, it makes it negative. So I'm going to go -3 times, does this match? Yes, this is the 4. So -3 times 4, -12. Well, that's kind of tricky. Almost got me there. And then I got some subtraction going on here, but I'm not even going to do subtraction because maybe you notice what's 5 to 5? 0. If you integrate anything, the lower boundary and the upper boundary are the same, you're going to get 0. You could break it up if you want, but it'll be 0 minus 0, which is 0. Awesome. That's the whole video right there. Good luck on the practice and the test prep, and I hope the match check goes well for you. Peace out.